Morning class, and welcome to this lesson on Geometric Optics 3, concave mirrors, concave mirror ray diagrams. Today we will be able to draw the three main ray diagrams for concave mirrors. So let's first discuss what a ray diagram is. A ray diagram, or also known as ray tracing, depending on what textbook you're using. A ray diagram or ray tracing is just a method. It's just a method for solving where an image will be located given a concave or a convex mirror. Okay, so we have this idea of ray tracing or ray diagrams. Now, what you need to do basically is memorize or understand or whatever that you basically have to draw two different rays. Okay, two rays in order to make this work. Okay, the first ray is going to be a line parallel to, or a line or a ray, I guess I should say more accurate, a ray that is parallel to the principal axis. And the second one is a ray that passes through the focal point. These two will give you your answer, and 9 times out of 10, or I think actually 10 times out of 10, this will give you full credit on a test. Okay, just drawing these two. Okay, there is a third ray that you could draw, and this is a ray that passes through the center of curvature, or the radius of curvature. And some textbooks show it, some textbooks don't. You typically never need it in order to get full credit on a test, but I will show you what it is on the first one just to give you an idea. Because if you're looking in your textbook, you might see this and go, what about this one? The reality is you need two, but you can use three if you want to. If you want to do a little bit extra. Okay. So let's take a look at this. First off, before I even start this, if you are doing this on your own piece of paper, use a ruler. Use a ruler. Okay. Exclamation point, use a ruler. Don't try and do this without a ruler. It gets frustrating. And if you're taking a test, bring a ruler to the test because you just want to use one to get it right. Because your drawing freehand could be off a little bit. So whenever you go to a test for this kind of topic, bring a ruler, okay? If you're taking AP, you're allowed to bring a ruler to the AP test specifically for this topic. Okay? So here we go. I am not going to use a ruler because I'm using a fancy board, and so I can use my tools in order to draw perfectly straight lines however I want to draw them. Okay? So let's draw a perfectly straight line using the awesome board. My first line, as you probably remember, is going to be parallel to the principal axis here. So we're going to draw it from the tip of the object. So, I should probably explain that first. I'm sorry about that. This object is standing up in this direction, okay? So it's trying to show you that this object is upright, standing above the plane, and is pointing up, okay? Maybe that didn't need to be explained, but I want to do it anyway. So let's draw a line parallel to the principal axis, okay? So already you can see this is line 1, okay? And it's going this way, okay? This is line 1. Now we know that when it hits a concave mirror, it's going to pass through the focal point. It's going to pass through the focal point. So we're going to draw a line from here straight through the focal point, okay? And I'm extending this out real big for dramatic effect. Okay, so this is still line 1. This ray is going this way. This is still ray 1. Okay, our second ray, as we defined earlier, is going to pass through the focus. So we're going to draw a line from right here, this point, through the focus. And if it passes through the focus, it's going to come off the mirror parallel. It's going to come off the mirror parallel to the principal axis. So let's and I should have made that a different color, I'm sorry. So this ray is coming down this way through the focus back to the principal axis. Now, already we can see that these two light rays converge right here. These two light rays converge right here. So I'm drawing a down arrow to show that this object is now going to be below the principal axis, upside down, and it's going to be smaller. Okay? Now, if we want to draw our third ray, just like we said in the, our rule 3, our third ray is going to be through the center of curvature, and as you can see, it passes right through there. And this third ray is actually going to hit the mirror and bounce straight back along the same line, and so you can see it's going to pass through the same point. Like I said, you can still have the answer with only 2 rays, okay? So I'm just showing you the center of curvature here, okay? So all the light rays are going to converge below the principal axis. This is what we mean when this is going to be a real image. This is going to be a real image, okay? Because light rays are actually meeting here. Light rays are actually meeting. And you can see, if we extend these out, if I draw the extension of these reflections, these will never converge, so there's going to be no virtual image in this situation. There's going to be no virtual image in this situation. So this is our first situation right here. We have an object that is hitting a mirror, and it is going to hit and reflect, and it's going to come right here. So when an object is beyond R or C, we are going to get an inverted. Notice this is upside down, an inverted, smaller, real image. Okay? It is inverted, it is smaller than the object, and it's going to be a real image. Okay? So that's situation number 1. Now that we have these down, we can go a little bit faster. Okay? Our next situation is going to be between the situation number 2, between R and F, okay? Or C and F. So notice it's in between these two. So let's draw our first ray. Our first ray is going to be parallel to the principal axis. Shoot. Let me fix that. Let's try this again. Parallel to the principal axis, and then it's going to come back through and then reflect through the focal point. Like that. Drawing it very big for dramatic effect. Okay, our next axis, our next line, I'll do green, is going to go through the focal point. And then it's going to bounce back and then be parallel to the principal axis. So you can see from these two diagrams that our image is actually going to be produced right here. Okay? Our image is actually going to be produced right there. Our image is going to be inverted. It is upside down. It is going to be larger than the original image or the original object, and it's going to be a real image. Notice if I drew the reflections, the extensions I mean, notice these two lines never cross, so there is no virtual image. There is no virtual image. And I'm not going to draw the third ray because I feel like you don't need to. You need 2 rays and you're good. Okay? So this is our next situation between R and F. Okay? First line is parallel. second line goes through the focus, and they come and converge right there. Okay, so if it's between these two, we're going to get a larger image as inverted and real. Okay, our last situation for this video is going to be an object. This is number 3. An object within F. Okay, so it's closer to the mirror than F is. So let's draw our 2. Let's draw our 2. Our first line is going to be parallel. Our first line is going to be parallel. Okay, and it's going to bounce back through the focus. Our next line still has to bounce off the mirror. So this is going to be a little bit different here. It's going to be a little bit different here. So let's do this light blue here. And I'm going to draw a line from right here up. Okay, let's pretend this light ray passed right through the focus. But it's not going to pass through the focus because it has to hit the mirror first. So this is our second ray. This is our second ray. And this actually is on a straight line. This actually is on a straight line with the focus right there. Okay, but it has to hit the mirror first. So notice, these two lines don't converge anywhere. These two lines don't converge anywhere. But if we draw their reflected rays or their extensions, if we draw their extensions, what we're going to get is we're going to get this extension right here. Okay, hopefully it's on the straight line. And then we're going to get this extension right here. And so what we're going to end up with is this image right here. So if we have an object within F, what we're going to get is we're going to get an image that is upright. That is upright. It is larger. And it is a virtual image. It is a virtual image because this is not an actual image. This is the reflections of the this is the extensions of the reflected rays. Okay, so those are 3 situations. I highly suggest as a student, what you do is you get a blank worksheet that has these kind of diagrams on there, just blank pictures showing you an object here, here, and out here, within F, between F and C, and then beyond C. Print off a few of them, and then each day draw your ray diagrams over and over and over again to get used to it. Because really this is all just practice. You have to practice drawing these ray diagrams over and over because it's easy to forget what to draw, okay? And you want to be getting accurate drawings here because this is what you're going to be required to do on the AP test. And you're going to be doing it fast, okay? Multiple choice and free response. You're going to have to be able to look at a question really quick, draw a quick sketch, and then have an answer telling that it's going to be inverted, upright, real, etc., etc., etc. The multiple choice questions and the free response questions are very difficult, and you want to be able to get these done quickly, okay? So I highly recommend getting some sort of worksheet and just busting through them like 3, 4, or 5 times to get a lot of practice. So those are the 3 ray diagrams for concave mirrors, okay? Our first one, beyond C, is going to be inverted, smaller, and real. Between C and F is going to be inverted, larger, and real. And then within F is going to be upright, larger, and virtual. So these are very difficult to memorize, and you're going to have a lot more coming with lenses next. So it's better not to memorize them, but to practice drawing them.